Let's finish talking about air pollution by talking about acid rain. Now, acid rain forms when you have regular rain or cloud droplets or water vapor in the air that condenses and in the meantime combines with either sulfur dioxide or nitrogen oxides, which we formerly called NOx. And when that happens, you get things such as H2SO4, which is known as sulfuric acid, and HNO3 or some variant thereof, which is known as nitric acid. So again, there are two ways this can form. You can either form acid rain, where you have your chemical combines with the water, and then it falls from the sky in the form of rain, or you can have acid deposition, where you have some surface and then you have your pollutant and your water. The water condenses and forms with the SO2 right on the surface. So you can go back to chapter 2 when we talked about deposition. Deposition is the change of state from gas directly to solid. And so you have both types of acid rain. You have acid rain and acid deposition. Anyway, so acid deposition can really be dangerous for ecosystems, particularly for lakes and buildings. If it happens around lakes, then it adds the acidity of the water, can affect the life within the water. If it happens on buildings, well, what happens is that the acidity of the rain and of the water chemically reacts with the limestone that buildings are made of. Here's an example of a statue made out of limestone. The first picture is a figure of the statue many years ago, and the statue on the right is a more recent picture of the same statue. What happened is because acid rain deposited onto the surface of the statue, you had a chemical reaction, which, for lack of a better term, literally melted the face of the statue away, the surface of the statue. So kind of morbid, not really a fun thing to deal with. Now, here's why we're worried about it here in the United States. The Ohio Valley, everywhere from St. Louis, Missouri up through Pittsburgh, Pennsylvania, that whole area is a big area for industry, and you have a number of coal-burning plants for that industry in the area. And so we have huge amounts of damage in the Adirondack mountains and forests. So it is a big worry. Now let me explain a little bit more about how this this chemical reaction happens. We can tell how acidic a substance is by using what's known as the pH scale. It is a scale from 0 to 14. Perfectly neutral would be right in the middle, a 7. Distilled water, pure H2O, would be a 7. It is a neutral substance. If you start having acidic compounds, then they start to become more and more acidic. The number actually drops. Rain is naturally slightly acidic at somewhere around a 5.5, a pH of 5.5. But it can get more acidic and reach a pH of 4.5. Just for comparison, you have acidic fruits like apples. Apples are really tart because of the acidity of the apples. Well, apples have an acidity of around 3.5, or pH of 3.5. Vinegar has a pH of 2.5. Battery acid, the acid in the battery in your car, has a pH of 1, extremely reactive and very dangerous. So you don't want to do this. The further away you are from being acidic, the smaller the number is and the more dangerous it can be. Now, have you ever done the experiment where you took vinegar and you combined it with baking soda? Yes, that would be the classic grade school volcano experiment. They have baking soda in the mountain. They drop a little bit of vinegar in it, and it starts to bubble up and froth over, and it spills over. Yes, great classic grade school experiment. Baking soda is something we call a base. Instead of mixing up with hydrogen compounds like what you do with an acid, so for example, there's sulfuric acid. It's SO4 combined with hydrogen. With an alkaline, it's mixed up with hydroxide, which is an OH compound. So you're going to have something with an OH at the end. Okay, so that's chemically what the difference is. You don't need to know the chemical difference between acidity, acids and bases. But the point is, if it starts having these OH compounds in it, it becomes more and more basic, which is just the opposite of acidity. And the pH level starts to rise. So baking soda is a base. Well, you have OH here and H2 here, or just even a single H. They combine, and guess what they form? Water. But in order to form water, they have to undergo a chemical reaction. Hence why when you mix vinegar with baking soda, you get this big, bubbly, frothy chemical reaction because you're forming water. Okay, now let's go back here to this picture here. You have statues. Well, you have acid rain, which is forming on the surface of the statues. But what is the statue made of? The statue is made out of something called lime. Wait, lime? I thought limes were acidic. They have citric acid in them. The fruit lime is acidic, yes. The fruit lime would be somewhere around here. However, when we talk about lime on the pH scale, we're talking about limestone. We're talking about a chemical in limestone, in cement, in mortar, between bricks themselves. It is a chemical that's common in all stones. So let me get rid of my baking soda and vinegar experiment. If you have limestone, which is very basic, and acid rain, which is rather acidic, and they mix together, you have an acid mixing with a base, you're going to have a chemical reaction, and the chemical reaction results in a loss, in changing the state of your surface. The lime is literally being reacted away, turning into water. Water and other substances as well. So where do we deal with acid rain problems across the United States? Notice that in the United States, all those green areas in this map here are natural rain. So a large portion of the Great Plains, along with large portions of the West, have natural rain. The pH level is pretty normal for natural rain. But as you go further east, you have a huge worry. Notice that red area? It's that whole area reaching from Missouri all the way through Pennsylvania that I've been talking about. It's the industrial belt, also known as the Ohio Valley. And there are lots of lots of industries in the area, produce a lot of pollution, creates a problem of acid rain. Here in Florida, we have to deal with a fair amount of acid rain as well, but nowhere near as much as they do in the Northeast. Okay, so what can acid rain do? You saw an example of what it can do to a statue. Here's an example of acid deposition in a forest of the Great Smoky Mountains in Tennessee. It is a problem, and we work continually to try and eliminate the problem of acid rain.